In this video, we're going to begin Chapter 7 and talk about Section 7.1 called the Ellipse. This chapter has 3 sections and they cover what we call the conic sections. Section 7.1 covers the ellipse, Section 7.2 will cover the hyperbola, and Section 7.3 we will revisit the parabola. So the definition of an ellipse is the set of all points P in a plane, the sum of whose distances from two fixed points, F1 and F2, is constant. These two fixed points are called the foci. The midpoint of the foci is called the center. So an ellipse could be orientated to where it's longer in the horizontal direction, as in this diagram, in which this would be called the center point. Your foci are a distance away from the center, or in the horizontal direction, or it could be longer in the vertical direction, in which here would be your center, your foci would be a vertical distance away from that point. So it will depend on which direction is longer in terms of how we're going to go about locating those two foci points. The definition here says that if I had any point along this outer graph labeled P, and if I found the distance from that point to F1, and then also found the distance from that point to F2, the sum of those two distances always adds up to the same number we'll call K, no matter where I am along this ellipse, and that's also true for this type. So the foci are located along what we call the major axis. That's the axis that runs down the center in the longer direction. So our standard form for the equation of an ellipse looks similar to that of a circle because the shape is similar. So we'll have x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. So the coordinates hk that come from inside of my parentheses here represent the center. The denominator under the x squared term we're going to refer to as a squared. So a, meaning its square root, is the distance from the center to the edge of the ellipse in the horizontal direction. So from my center point hk, we're going to move left a and right a to get to the edge, these 2 points. B, which is found by square rooting the number under the y squared, is the distance from the center to the ellipse in the vertical direction. So from my center point HK, move up B and down B to get to the edge, and then those 4 points can be used to sketch the graph. The foci are located a distance of C units from the center, where C is found by taking the square root of, and the book writes this as the absolute value of a squared minus b squared. However, basically you're just subtracting your denominators in the order in which you get a positive number, because you can't square root a number if it's not positive. Okay, so that's how you find the distance. You take the square root of the difference between the denominators and making sure that's a positive. That's the value of C, and you move from the center in whichever direction is longer. So if it's longer horizontally, you add and subtract that number to the x value of the center to get to your foci. And if it's longer in the vertical direction, you will add that and subtract that number from the y coordinate of the center to get to your foci. So our first example here is x squared over 16 plus y squared over 49 equals 1. So this has a center at 0, 0. The a value is found by square rooting 16, so a would be 4. And the b value is found by square rooting 49, which would be 7. So we could just use that to plot our graph. 0, 0 is the center. Left 4, right 4. Put 2 points there. Go back to the center. Up 7, down 7. 2 more points, and then those 4 points create the graph. When you have to state the foci, you calculate the distance away from the center. So for an ellipse, it is c equals the square root of, and you just have to subtract the denominators in the order that you get a positive answer. So whichever one's bigger, you're going to start with that one. So 49 minus 16, so the square root of 33. In this case, since B is larger than A, in other words, it's longer in the vertical direction, we add and subtract that number from the y coordinate of the center. So our center was 0, 0, so we're going to add and subtract that square root of 33 from the y coordinate, giving our foci location as 0 square root of 33 and 0 negative square root of 33. You do not have to plot the foci on the graph. You just will need to be able to state where they're located. Our next example is similar. 4x squared plus 25y squared equals 100. However, this one is not in standard form. It's close, but it's not quite there because the right side is not a 1. So our first step would be to divide everything by 100 to make the right side equal to 1. So when I divide by 100, the right side turns into a 1. Here, 4 over 100 would reduce to x squared over 25. The 25 over 100 would make the second term y squared over 4 equal to the 1. So once we get to here, again, our center is 0, 0. 25 is the a squared, so a is 5. 4 is the b squared, so b is 2. So that's all I need to draw the graph. 0, 0, left 5, right 5, and then back to the center, up 2, down 2. Draw the shape. Foci, C would be equal to the square root of, subtract the denominator starting with the bigger number, so the square root of 25 minus 4, which is the square root of 21. This time, since A is larger than B, in other words, it's longer horizontally, we're going to add and subtract from your x coordinate of the center to find your foci. So my foci was 0, 0. I add 21, square root of 21 and subtract square root of 21 to the x, giving me square root of 21, 0, and negative square root of 21, 0. Our next example, we have standard form given, but our center is not at the origin. Basically, that's the only difference here. So x minus 4 squared over 9 plus y plus 1 squared over 16 equals 1. So our center would be located at HK, which would be 4, negative 1. A squared is 9, so A is 3. B squared is 16, so B is 4. Locate your center. 4, negative 1, right here. Left 3, right 3, plot 2 points. Back to the center, up 4, down 4. Plot 2 more points, and then sketch your graph. My graph is a little bit sloppy, but that's what the shape should look like. Locating the foci, C equals the square root of 16 minus 9, or the square root of 7. Since B is larger than A, it's longer vertically, so we add and subtract this number to the y value of the center. So 4, comma, negative 1 plus square root of 7, and then 4, comma, negative 1 minus the square root of 7. We're adding and subtracting the square root of 7 to the negative 1. All right, our last example is another one that is not in standard form. However, this one's going to take quite a bit of work to get it there because it's not really even close. However, I can tell that this is an ellipse because I got a 4x squared plus a 9y squared term. Notice that I have x squared and y squared terms and their coefficients are both the same sign. So they're both positive, but they're not identical. If they were exactly the same, it would be a circle. But since they're not the same, but they're both positive, that's how we know it's an ellipse. All right, so if it's not in standard form and it looks like this, where I have an x squared term and an x term, and I also have a y squared term and a y term, we're going to have to complete the square to put it in standard form. So our first step would be to start with x squared plus any other term involving x, which is the 32x, followed by the y squared, 9y squared, plus any other term involving y, 36y. And then constants need to be pushed to the other side. So subtracting 64 gives me a negative 64 on the right side. So the next step is within the x variables, your next step is to factor out the leading coefficient, 4. Just the 4, not an x. So we factor out 4. That would have left us with x squared plus 8x plus, and then we had a blank here. So if this was a blank, at that time, we put a blank on this side to balance that out later. Here, same thing. We're going to factor out the coefficient 9 from just the y term. So that would leave y squared, and if I took a 9 out of this term, that would leave 4y plus blank. We didn't know what this was yet, so if I'm going to add a number there, I'm going to have to add that same number here. So we would put a blank on the right. To fill in the blank, we complete the square. So we take half of 8, which is 4, square it, we get 16. So that number goes right here. However, since I'm putting that number inside of my parentheses, this number that I factored out, 4, you'd have to multiply that by this number to know how to balance it out. So because 16 times 4 is 64, we're balancing that by adding a 64 on the other side. Same thing here. 4 is my coefficient of y, so half of 4 is 2. Square it gives me a 4. That goes inside the parentheses. However, multiplying it by what I factored out is really a 36, so to balance that, we're going to add a 36 to the other side. So next I have the 4 still sitting out in front. This thing now should factor. It factors into x plus 4 quantity squared. Plus 9. This trinomial factors into x plus 2 squared equals, these numbers would add up, these would cancel, so we would just add up to a 36. And then like the one we saw earlier, if this number's not a 1, it has to be a 1, so we're going to divide everything by 36. So that would leave a 1 over here, and then reducing here we get x plus 4 squared over 9 plus, reducing this, we get y plus 2 squared over 4 equal to 1. Once we get here, it's just like the last example. H would be negative 4, K would be negative 2, so our center would be at negative 4, negative 2. A squared is 9, so A is 3. B squared is 4, so B is 2. So negative 4, negative 2. Left 3, right 3, plot 2 points. Back to the center, up 2, down 2. Draw the graph. Foci, C would equal the square root of 9 minus 4, which is the square root of 5. Since A is larger than B, we move horizontally from the center to locate the foci. So we add and subtract the square root of 5 to the x value of the center, so to the negative 4. Negative 4 plus square root of 5, with y being negative 2, and then negative 4 minus square root of 5, with y being negative 2. So that is section 7.1 on the ellipse.